So it's summer and the World Cup has started. And of course all of us want to know the World Cup winner. That's why in this video, I'm going to try to use my statistics knowledge from AP Stats to try to predict the World Cup winner. AP scores released also, and you can trust that I know what I'm doing because I somehow got a 5. But yeah, let's get started. So in typical AP Stats fashion, I need to find my research question first. So I'm going to ask, can I use soccer match data to predict future match outcomes? So I need to have some response and explanatory variables. I'm going to look at home wins, draws, and away wins. Now for the explanatory variables, so I'm going to use form diff, which is basically home team recent form minus away team recent form. I'm going to use attack diff, defense diff, neutral home games, and away games. So I'm on Kaggle right now, and it gives me the international football results from 1872 to 2026. So as you can see here, I really only need the results because everything else doesn't matter as much. And as you can see, there's date, home team, home score, away score, tournament, city, country, and neutral. So what I'm gonna do is I'm gonna click open with and then Google Sheets. Sorry for the flashbang, but what I'm gonna do first, I'm gonna click on the first row. I'm gonna freeze it. So I'm gonna go view and then freeze. So I need to see, are the dates sorted? So let me go on the date column. I think they're sorted. It goes to 1872. Bro, this is before World War I. This was like the Reconstruction era, like not long after the Civil War. Okay, that's actually crazy. So I need to see, it looks like the home and away scores are all numbers, which is good. I'm predicting that Spain will win, England will win, and of course Argentina, fixing the matches, 49,506 matches over how many years? Like 200? No, not 200, but like a lot. So now I'm gonna go to VS Code. I'm gonna create a new folder. So inside this, I'm gonna create a couple folders. One is gonna be data, one is gonna be models, and then finally I'm gonna do SRC. Now inside the data, I need to have some raw data, so I'm gonna put raw. And then inside the raw, I need to have the results. Now I'm gonna create a folder here, and it's gonna be called processed. And then in the SRC, I'm gonna create 2 Python files. One is gonna be prepare data, train_models. And I'm a beginner because I don't even have Python installed. That's kind of embarrassing. Machine learning is basically using old data to find patterns and then test whether those patterns work on new data. And then I need to import, I think it's called pandas, which is like a training thing. So from what I understand, the raw path is basically what I have right here. It goes to results. And then the out path is going to be the processed, which is going to be in here. And it's going to be the matches features. So to get the match results, if the home score is greater than the away score, then it returns the home score because that means they won, right? And if it's less, then it's an away win because the other side won. And then if these 2 conditions are met, well, it has to draw. What else can it do? I don't think I have Panda installed. Okay, so I don't think I have Panda installed because it says no module named pandas. So I'm going to install pandas. I think I need to install some other stuff later on because I need to use scikit and joblib. Hopefully it goes into the processed. Okay, good. Thank God. Yeah, everything looks right. I'm going to use logistic regression. Basically, it just predicts categories. And I want to predict the home wins, the draws, and the away wins. So it gives like probabilities. And then I'm going to use random forest. Random forest is just like a collection of many decision trees. Random forest basically combines many of these trees and then averages their opinions. So now I'm going to open the train models. Once again, I need to import like the pandas and scikit, whatever, all the stuff. Now I'll have the data path and also the model directory. So model fit basically trains the model. This predictions, this makes the predictions on the test data. This is pretty self-explanatory. Accuracy is just accuracy. And then right here we have the logistic regression, which is what we want. As you can see, everything ran correctly. This is the accuracy. It's not that bad because it's kind of hard to predict soccer. So the logistic regression has accuracy of 53.29%, which is the most out of all of them. So right here, as you can see, the classification report. The precision basically tells you when the model predicted the result, how often was it right. And I can say it's kind of low. There's 0%. And then recall is basically of all the actual results of this type, how many did the model actually catch? 0% is kind of low, I'm not gonna lie. F1 score basically is like a balance between precision and recall. Now let's look at the logistic regression. For the away, precision was 49%. Draw was still 0, which is pretty bad. This one actually had percentages for all of them. I'm surprised this one had the lowest accuracy. I don't know if they're correlated actually. This one had a 45%, 64%. Wow, that's pretty high. And then this one actually was able to predict a draw 24% of the time. For my model, I basically can say that my model needs to be at least like 47.8% to actually be like of some use. The logistic regression is pretty high, but the random forest is really low. Probably because I set it to balance, which means, as you can see, all of them are kind of balanced as opposed to having a 0% in draw. So what I kind of want to do is I want to improve the model. What I want to do is I don't want to use random forest on just one setting. You know, I had the class weight as balanced before. I might want to add new ones. And then I also want to add something called like a validation set. Right now, it's basically trains before 2022 and then tests 2022 and later. But I kind of want to have like a validation set. So the training set would be before 2020 and then the validation set would be 2022, 2021. And then the test set would be 2022 and later. As you can see right here, there is a class weight balanced, but I'm adding all this extra stuff. So it's not just one setting. So let's try to run this. So I ran it again. As you can see, the baseline is like the same basically. The logistic regression improved to 55. The balance is slightly less with 54. So the test accuracy is 52.49%. So overall, it seems like the random forest depth 10 is the best because it has some good log loss and also like the accuracy is pretty good. So my prepared data, basically what I did is I used the last 5 matches, but now I kind of want to use 20 matches. Because if you think about it, if a really good team, such as France, just loses randomly a couple games, then the model will treat it as if like they're like a terrible team, when we pretty much know they're like probably one of the best teams, if not the best team right now. So what I want to add is the last 20 matches instead. Now I'm going to run it. So now I ran the prepared data, and then I need to go back to the training model. I'm just going to update the features list. Now I'm going to run it and see what happens. So as you can see, it still like almost never predicts the draw. 0, 0, 0.3, 0, 0. So I want to compare like the average predicted probabilities to the actual result proportions. So I'm going to add this. So this is actually really good. As you can see right here, this basically tells me that even though the model like never chooses draw as the final predicted class, average predicted probabilities are actually pretty close to the reality. As you can see, they're like decently close. So I'm going to keep note of my statistics right now and see if when I improve my model, if it's any better. So my best model is the random forest depth 10, accuracy, balanced accuracy, and then log loss. Now what I'm going to try is I want to do ELO system. Basically, if a strong team beats a weak team, you know, nothing happens. Nothing surprising happens because they're supposed to beat them, right? But if a weak team beats a strong team, then the weak team gains more ELO. So what I'm going to add is something called ELO diff. I think this is better because it describes the team better. What I'm going to add is ELO. I'm going to add home ELO, away ELO, ELO diff, and then like a bunch of more like adjusted expected stuff. So I'm going to run the prep file. Look, it has home ELO, away ELO, ELO diff, adjusted and expected. Now of course I need to update my feature list now because I added more settings. Now I'm just gonna run the train model and see. So for my logistic regressions, as you can see, before I looked at anything I saw this. It says stop total number of iterations reach limit. So I probably want to fix this to imports because I need to add some standard scalar to fix this issue. So I have the 2 regressions right here, the logistic regression and then the logistic regression balanced. But now I made it scaled, so I'm gonna change this a bit. I wrote down the data after I changed it to an ELO system, and as you can see, much better. See the log loss decreased by a lot, and accuracy is increased a lot. Now I would be dumb if I were to stop here, so what I'm gonna add is something called gradient boosting. Basically it's just another machine learning model. I think it's part of scikit, so I'm just gonna go here and I'm gonna add this, and then in my models list I'm just gonna add gradient boosting. What I need to do now is simulate the World Cup. So as you can see right here, I made this number of simulations 100, but I kind of want to do more, so I'm gonna do maybe 10,000. Yeah, it's 10,000. And then after that, I added a code right here. Basically, it'll print into this simulation results. So if I run it, it should use my machine learning model to basically print out the results. So I click run, and it should run. So as you can see, everything finished. By the time of this recording, Spain and Belgium played their game, and I think today is like Norway versus England. And it says that Spain had like a higher chance of winning, which they actually did. It was 2-1, I'm pretty sure. fixture. Today, it looks like England has a higher chance of winning, and then of course Argentina. So let's go to this. Wow, okay. Basically this tells you the simulated titles and the championship probability. We're just gonna look at here. Basically it tells you the probability that they would win. Surprisingly, Argentina has the highest. That's actually really surprising. And France is third. Spain is higher than them somehow. Norway has the least amount. Sorry, Holland. And then Switzerland has a higher chance. So that's gonna wrap it up for this video. I actually learned a lot of interesting stuff, especially how somehow Argentina has the highest chance. I think it's because it takes like a lot of data from like way back then when Argentina was good, when like, you know, Maradona, Batistuta. But wow, I didn't expect Argentina to have a high chance of winning. This isn't certain that Argentina is gonna win, but it has the highest chance. With the data from 2020, I used a validation set for 2021 and 2022 to basically predict the World Cup.